Hello ladies, this is for our small group today on December 22nd. If you did not attend small group or if you just want to see further examples, please watch this video. It has to do with lesson 4-2, addition and subtraction of polynomial expressions. So make sure that if you're ever struggling with a skill, you come to small group with Miss Townsend and I. It will be every Tuesday for the duration of remote learning from 1:35 to 2:30. We can go over extra practice, we can go over some delta math, all that stuff. So please, please, please attend. And yeah, that's it. So if you wanted to see a video explanation of how these questions are done, look no further. The video's here. There are 4 addition examples and there are 4 subtraction examples. I'm going to walk through how to do each of these very, very detailed. So our first 4 questions are all addition of polynomial examples. If you remember watching the lesson from today, when you do addition of polynomials, you just drop your parentheses. So I'm going to just drop my parentheses and go ahead and add. So I have 4 plus 2n cubed, or 2n to the third, plus 5n to the third, plus 2. And remember, all your answers should be in standard form. The first thing we're going to do is we're going to see, does a 4 have a like term? You betcha, the 4 has a like term with my 2. 4 plus 2 is 6. Then I have to ask myself, does my 2n cubed have a like term? It does. It has a 5n cubed I can combine it with. So 2n cubed plus 5n cubed is 7n cubed. Here's the issue. I don't want it written like 6 plus 7n cubed. I want it written as 7n to the third or 7n cubed plus 6. And that's your final answer. That's how you add 2 polynomials. If you want, you can pause the video now and try to do the rest by yourself, or you can continue watching. So in our second example, we have 9r cubed plus 5r squared plus 11r plus a minus 2r cubed plus 9r minus 8r squared. Remember, we just drop our parentheses. So I'm going to have 9r cubed. My r's look like v's, just a heads up. Plus 5r squared plus 11r minus 2r cubed plus 9r minus 8r squared. And we're going to highlight our like terms. So I'm going to use yellow. Let's see what I can combine with my 9r cubed. I can't combine a 5r squared, can't combine 11r, but I can combine a minus 2r to the third. So I say to myself, what's 9r to the third minus 2r to the third? You're only combining the coefficients. So 9 minus 2 is a 7. So I have 7r cubed. Now, what can I combine with my 5r squared? Well, I can combine with my minus 8r squared. 5 minus 8 is negative 3, so I have minus 3r squared. Now, I look, what can I combine with 11r? I can combine it with 9r. 11r plus 9r is 20r. And if I look, this is already in standard form because I'm in descending order for my exponents. So this is my final answer. Now, number 3 is a little different. There's no parentheses, but that doesn't matter because when I'm doing addition, I can just go ahead and do it. It's sort of like Nike, just do it. So I'm going to rewrite my expressions. So I have negative 3x squared plus 4y. And I want to combine it with a 5x cubed, a negative 6x squared, and a minus 3y. So I go ahead and start combining. What can I combine with minus 3x squared? I can combine it with minus 6x squared. So minus 3 minus 6 gives me a minus 9, so I have minus 9x squared. Now I ask, what can I combine with my 4y? Well, I can combine it with minus 3y. 4y minus 3y is a plus 1y. If you want, you can just write plus y, not a big deal. And then if I look, I only have a 5x cubed left. Everything else is already highlighted. It's already combined everything with what it can be combined with. So I'm just left with plus 5x cubed. But here's the issue. I'm not in standard form, so I have to put it in standard form. So my 5x cubed comes first, and it's positive, so I'm going to keep it positive. I then have my minus 9x squared. I have to keep it minus. And then I put my plus 1y. And that's your final answer. So you should be at the point where you can try to do the next problem by yourself. If not, come ahead and watch. So it's addition. I'm just going to drop my parentheses. So I have x squared plus 3x plus 1 plus 2x squared minus x minus 2. And what I'm going to do is I'm going to put a 1 in front of my x and a 1 in front of my x squared as a reminder that there are 1x squared. There is a 1x. I need to ask myself what I can combine with 1x squared. Well, I can combine it with my 2x squared. 1 plus 2 is a 3, so I get 3x squared. Now I need to ask myself, what can I combine with 3x minus 1x? 3x minus 1x is a positive 2x. And then last but not least, I have a plus 1 and a minus 2. 1 minus 2 is a minus 1 or a negative 1. So I get 3x squared plus 2x minus 1. And that's my final answer. Okay, so those were all addition examples. Now what we're going to do is we are going to do some subtraction. So whenever we do subtraction, we want to do keep, change, change. So keep, change, change. So we're going to change it into an addition problem and then just carry out all of our signs. So I keep my first expression the same. So I keep my 3x squared plus 4x minus 8. And I want to do 3x squared plus 4x minus 8. Take away a negative 2x squared plus 4x plus 2. So I change this to addition, and then I make everything on the inside opposite, or I change it. So I have a positive 2x squared, a minus 4x, and a minus 2. Now I drop my parenthesis. So I have a plus 2x squared minus 4x minus 2. What you're basically doing is you're really just distributing a negative 1. Let's go ahead and combine. So what can I combine with 3x squared? I can combine it with 2x squared. 3x squared plus 2x squared is a 5x squared. 4x is positive. 4x minus 4x is 0x. So you don't have to write 0x, but what you can do is, and what I typically do and what Miss Townsend typically does, is we cross it out to show that we're canceling them out. Now, minus 8. Minus 2, negative 8, and negative 2 will give me a negative 10. So I get 5x squared minus 10 as my final answer. Let's go on to our next example. Remember, keep, change, change. So I keep my first expression. So 12a to the 5th minus 6a minus 10a cubed. Change this to addition, and then I make everything opposite. So minus 10a, a plus 2a to the 5th, and a plus 14a to the 4th. So I'm going to write minus 10a plus 2a to the 5th plus 14a to the 4th. Now we're going to go ahead and combine. What can I combine with 12a to the 5th? I can combine it with 2a to the 5th. 12a to the 5th plus 2a to the 5th is 14a to the 5th. What can I combine with minus 6a? I can combine it with negative 10a, or minus 10a. A negative 6a and a negative 10a will give me a negative 16a. Then last but not least, I have my minus 10a cubed plus 14a to the 4th. Those are not like terms. So I just write my minus 10a cubed. And I write my plus 14a to the 4th. And if I look, none of this is in standard form, so I have to put it in standard form. I like where my a to the 5th is, so I'm going to rewrite it as 14a to the 5th. Then I'm going to write my 14a to the 4th, because that's my next highest exponent. Then my next highest exponent is my minus 10a cubed. And then my next highest one is my last term, my minus 16a. And that's your final answer. Now, we need to pay very close attention. From comes first. Say it for me. From comes first. So when I solve this example, I want to do subtract 5x squared plus 2x minus 11 from 3x squared plus 8x minus 7. So this is a regions question. So what I want to do is from comes first. So I'm going to write my 3x squared plus 8x minus 7 first. I'm going to take away a 5x squared plus 2x minus 11. Remember, keep, change. So this is going to turn into a positive, minus, positive. So I have 3x squared plus 8x minus 7 minus 5x squared minus 2x plus 11. We now combine our like terms. So what can I combine with my 3x squared? I can combine with my minus 5x squared. 3x squared minus 5x squared is a negative 2x squared. I like how this problem's going to work out. You'll see why. I have my positive 8x that I can combine with my minus 2x. So positive 8 and a minus 2 is going to give me a positive 6. And then last but not least, minus 7 and positive 11. Ooh, it's like going to 7-Eleven. Negative 7 plus 11 is a positive 4. And the reason why I like this is because guess what? It leaves in standard form. Great question. Now, number 4. These I didn't put on your Delta Math assignment, but they can pop up on Delta Math, and they definitely pop up on the regions. It's called substituting polynomial expressions. So, number 4, if a is equal to 3x squared plus 5x minus 6, and b is equal to negative 2x squared minus 6x plus 7, then a minus b is equal to what? So here's how I approach. I rewrite what I'm given. So I'm rewriting a minus b. And I don't know what it's equal to. But here's the issue. I do know what a is. A is 3x squared plus 5x minus 6. So I'm going to put that in for a. I'm now going to do my minus, and I know what b is. But the thing is, since that's such a large expression, I'm going to put it in parentheses. Now we're going to do keep, change. So I'm going to keep my 3x squared plus 5x minus 6 the same. I'm going to change this to an addition, which means everything on the inside I'm going to change signs. So positive, minus. So I have my plus 2x squared plus 6x minus 7. Now we combine our like terms. 3x squared I combine with 2x squared. That's going to give me 3x squared plus 2x squared is 5x squared. Now my 5x I combine with my positive 6x. That's going to give me 5x plus 6x, which is 11x. And then last but not least, minus 6 with a minus 7. Well, I know negative 7 and negative 7 is negative 14, so negative 6 and negative 7 must be a minus 13. And I get 5x squared plus 11x minus 13 as my final answer, which is choice 2. And that's it. So if you have any questions, please email myself, Miss Townsend, or Miss Jimenez. And remember, small group every Tuesday from 1:35 to 2:30. Have a great day, ladies.